Hello guys, welcome back to this Arduino tutorial series. So in today's video, we are going to understand the use of PWM pins and we'll try to control the speed of a DC motor using our Arduino microcontroller and a potentiometer. So let's get started. So this is our Arduino microcontroller. So you know that these are the digital pins of our Arduino board. That means these pins are having only two states, low and the high state. Low for the 0 voltage and high for the 5 voltage. When you are using these pins, the output pin. But if you want a voltage value between 0 and the 5 volt, for that you need a digital to analog channel, which is available in the Arduino Uno board, and the pins that you can use for this purpose are called the PWM pins. For example, pin number 3, pin number 5 and pin number 9 are the PWM pin. There are other pins in this series of digital pins that are called the PWM pins. They are used to convert analog signal to a digital signal to an analog value. That means that are used to uh, generate a voltage value from 0 to 5 voltage. So this DAC channel means this digital to analog converter of our Arduino board is having a size of 8 bits. That means it is having 256 discrete value for a voltage from 0 to 5 voltage. So for example, if you want to get a voltage of 5 volt from these PWM pins or value of high state of this PWM pin, you will not be getting the 5 as the output. You will get 255 as your output, which is indicating that your state of the output pin is set to high and the voltage is 5 volt. So these PWM pins are used to control the output power of your load. For example, you want to control the brightness of your LED or a lamp, so you can do with the help of these PWM pins. If you want to control the speed of a motor, then you can use these PWM pins to do so. So this was the basic explanation of the PWM pins. So let's interface a DC motor here, and we will control its speed using the potentiometer. And connect the output of this potentiometer to pin A0 of the Arduino board. Now let's go to the coding section. I have created a variable A and have assigned a value 9 to my variable, then float value string A. So this thing is not required for now. Okay, Z and Z. So let's comment this section. This is not required for now. So in the serial, so I'm using my pin number A as my output pin. I'm reading the value of the output of my potentiometer at analog pin A0, and I'm storing the value to a variable to floating variable value. But we know that ADC channel is having a size of 10 bit and DAC channel is having a size of 8 bits. So you have to convert the output, that 1023 discrete values, to a value to 255 values. Just like the previous video, we converted the analog values that we were getting on the pin number A to values to a value of 5 volt. Similarly, you have to convert that values to 255 in a range of between 0 to 255. So in this way, you have converted 1023 discrete values to a value between 0 to 255 values. So now compile this code. We forget to terminate this command here, and let's add another command here. Now I'm printing the value of this val variable value variable using the serial.println function, and I'm waiting for 200. I have given a delay of 0.5 second. Now compile this code. Now double click on your motor and set its revolutions, normal revolutions, to any value. For example, I'm setting it to 100 revolutions per second per minute RPM. So now run your simulation circuit. I forget to add a ground here, so just go to place, terminal, and ground. Select ground and place it here. So our circuit is complete. Now compile your circuit and vary the uh, output of potentiometer. Here you can see. Let's reduce the voltage or the value of potentiometer. In the similar way, you can see that when we are getting 0 as the value of our value variable, the speed of motor is 0, because we are this analog write function having the two argument takes the two argument. First is the pin number and another is the value of voltage, which is in between 0 and 255. Instead of accepting the exact voltage value, it's accepting the value in between, corresponding value of voltage from 0 to 255. So for 5 voltage you have to type here 255. But now we are changing the value of this variable with the help of our potentiometer. So let's vary the value output of our potentiometer. You can see the speed of our motor is increasing as the output of our potentiometer is increasing. So this is the normal speed of our half of the speed of our motor. Now let's give a 5 voltage supply to the motor. So you can see, after giving a 5 voltage supply, this is the highest speed, or this is the full speed that motor can revolve. So this is all for today. Thank you so much for watching.